This problem is, let's read it. It's x minus 7 times the square root of x plus 10 equals to 0. This is a more of an obvious quadratic form. It actually is a quadratic equation if you look at it the right way. And it's not a true quadratic equation, but it would be if you were thinking in terms of the square root of x. So for example, if I think of x as the square root of x squared minus 7 times the square root of x, and then plus 10 equals to 0, and I'm going to put that in parentheses just so it's a little more visual. This is a quadratic equation in the variable square root of x. Alright, so it's because what is a quadratic equation? A quadratic equation has a number out here multiplying something squared. Now my number out here is 1, but in other words, there's a squared term, variable squared, and then plus or minus some number times the variable to the first power, and then a constant number added or subtracted. So I have, it would be like this. You know, if I had this equation, if I had y squared minus 7y plus 10 equals to 0, this is obviously a quadratic equation. We have a squared term, the first power, and a constant. And this is in variable y. Now, if you look here, what is the difference in these equations? The only difference is that we call this the square root of x, and down here we call it y. And so other than that, they are identically the same equations, just a different named variable. Alright, so we can possibly, well, we could use actually anything we know about quadratic equations, solving them we can use to solve this problem. But we're solving for the square root of x initially, and then eventually you get to x. You solve for x. So it's a couple steps there. Now, there is an alternative way of doing this problem. We could isolate the square root term. For example, if I added this term to the right side and then squared both sides, that would eliminate the square root, and then we could solve from there. And there's nothing wrong with that method at all. It's a fine method. But you know, my purpose in this topic is to introduce the quadratic forms to you. And this seems to be a fairly lighter one in which to start to do that. Okay, now I'm going to factor this. And factoring this equation is very similar to factoring this one. In fact, how would you factor this? This would be y minus 2 times y minus 5 equals to 0. So you can verify that. This is y squared. Minus 5y minus 2y is minus 7y. And then here's plus 10y. That would work. And so when I go to factor this problem, I'm factoring by using the square root of x. Square root of x in both parts. And then to get these numbers, I need two numbers to multiply together to get 10. And that would probably be 2 and 5. And to make that positive and this negative, these have to be negative. So there it is, factored. It's been factored. Now I'm going to erase this now. But anyway, we took this problem and literally factored it by using square root of x as the base term here. Now, I'm going to set each of these equal to 0, because again, we're multiplying two parts to get 0. Then we solve factoring by setting each equal to 0. So, and we'll solve these. I add 2 to both sides here. I get square root of x equals to 2. Add 5, I get square root of x equals to 5. And then we're not done because we haven't solved for x. So I'm going to now square both sides of the equation in both cases. And I get x equals to 4 here and 25 there. So there are answers. Now, as before, if you have an equation with a square root in it, then there's that potential for error. And so we need to check our answers. And I don't know what's right here. Honestly, don't. Sometimes it's possible you can check these and neither one of them works. They both might be wrong. It could be both of them are okay. It may be just one of them is not okay. So we need to check, because once again, I know I'm saying this a lot, but I like to emphasize the important things, usually by telling it a few times, that you know, this method of solving, the way we solve square root equations carries a potential for error in it. There's a weakness in the method. There really is no other real practical method. Because if I did the other one, if I isolated the square root term, I still have to square both sides of the equation. And so, alright, so let's check. And we'll put x equal 4 in first. So I get 4 minus 7 times the square root of 4 plus 10 equals to 0. And so this is 2. 7 times 2 is 14, so I have 4 minus 14 plus 10 equals to 0. And that checks out. That does check out, because all this stuff will cancel. So 4 is a good answer. Let's try 25. And so I have 25 minus 7 times the square root of 25 plus 10 equals to 0. So we have 25 minus, now here I've got 5 times 7 is minus 35 with a negative, plus 10. So 25 minus 35 plus 10 does equal to 0. Those also cancel off. So here we end up with both answers are correct. And so there we go.